Dear Axer, I've been having trouble helping my son Pedro with his math homework. It's dividing fractions. I thought I knew what I was doing. You just keep, change, and flip. But he's going on about common denominators. I need your help. What is he talking about? From Cecilia.
Hey Cecilia, thanks for the letter. Let's take a look at a word problem to help us out. Mr. De Leon is baking cakes. How many 1/2 cup servings of cake mix are there in a pack that has 3 1/4 cups in it? First off, in order to tackle this problem, we have to convert this mixed number into an improper fraction. To do this, we multiply 4 times 3 and add 1, which gives us 13/4. Now our problem is 13/4 divided by 1/2. I'm assuming that by keep, change, flip, you meant keeping the 13/4, changing the division to a multiplication, and flipping our 1/2 to a 2/1, which is actually the reciprocal. So if we multiply across, we get 13 times 2 is 26, and 4 times 1, which is 4. In essence, this gives us 6 2/4. We can divide 4 into 26 and get 6 wholes, and we're left with 2 pieces out of 4. This can be simplified to give us 6 1/2. In order to really understand what Pedro is doing, we have to pause. What are common denominators? Well, let's take this problem for instance. 1/2 plus 2/3. In order to add these fractions, we need to find a common denominator for 2 and 3. The way that we do this is we list out the multiples of 2 and 3. Let's take a look. The multiples for 2 are 2, 4, and 6. For 3, we have 3 and 6. The first one that they have in common is 6. So we've decided that 6 is going to be our common denominator. Now we need to take 1/2 and change it to a fraction that has 6 in the denominator. In order to do that, we've multiplied by 3/3. This is okay because 3/3 is just 1, so we're not really changing the size of the fraction. 1 times 3 is 3. 2 times 3 is 6. We do the same for 2/3. 2/3 times 2/2. 2 times 2 is 4, and 3 times 2 is 6. Now we both have 6 in the denominator. 3 6 plus 4 6. We can just add across because the denominators are the same. 3 plus 4 is 7, and we keep that 6 as the denominator. Now we wind up with 1 and 1/6. Let's get back to Pedro. Pedro's problem is 13/4 divided by 1/2. Again, we look to see what the denominators are. They're currently 4 and 2. We really want to find a common denominator, so we list out the multiples of 2 and 4. 2's multiples are 2, 4, and we could continue, but we can quickly see that 4 is going to be the common denominator. Now, because 4 is the common denominator, 13/4 can stay the same. We do need to change 1/2, however. 1/2 times 2/2. 1 times 2 is 2. 2 times 2 is 4. So our new fraction is 2/4. Now we have 13/4 divided by 2/4 as our new problem. Because the denominators are the same, we can then just divide 13 by 2 like we did with our addition problem. 13 divided by 2 equals 6 1/2. How do we get this? Well, we divide. 2 goes into 13 6 times. 6 times 2 is 12, and we have 1 as the remainder. So we have 6 whole pieces and 1 remaining out of 1/2, which is exactly the same as what we've got with our keep, change, flip model. But this time, Pedro just found common denominators, which is pretty much what he was telling you about. Now the big question to ask ourselves is, why does this work? So I always tell my students, let's draw a picture to help out. When in doubt, draw it out. So this was the 3 1/4 that we had originally had. We know through our conversion that this is actually 13/4, which you can see. 1 whole equals 4/4. A second one would be 8/4 in total. A third one would be 12/4, and that extra fourth gives us 13/4, which is the same thing that we got when we were converting. Now, We're trying to see how many halves can fit into 13/4. But we know that 1/2 is simply 2/4, which is what Pedro did when he was converting. Now that we know that 2/4 is 1/2, we can see how many times that fits in. So it's going to fit in once, twice, a third time, a fourth time, a fifth time, a sixth time, and up. We didn't get the quite fit that we wanted to, but we got half of this. So it fits in 6 whole times, 1, 2, 3, 4, 5, 6, and half. So we can see that we get 6.5. Now, in case you're not 100% convinced, let's take a look at another problem before we go. Our word problem is, a chocolate box is 4 6/8 inches long. Each chocolate is 1/4 inch long. How many chocolates will fit in the box? So again, we take our 4 6/8. 8 times 4 is 32, plus 6 is 38/8. Now we're dividing this by 1/4 inch to see how many chocolates can fit into here. As Pedro would do, we look at the denominators, 8 and 4, and we find the common denominator by finding the lowest common multiple. We see that they're 8. Once again, we have to take our 1/4 and make it so that the denominator is 8. To do this, we multiply by 2 halves. 1 times 2 is 2, 4 times 2 is 8. So our new problem is 38/8 divided by 2/8. Since the denominators are the same, we can go right ahead and divide. 38 divided by 2 is 19. You can do this in various ways. You can skip count, or you can do the old-fashioned division. Now, if we take a look at how this happens in our keep change flip, we see that we have 38/8 divided by 1/4. We would keep the 38/8, we would change the division to a multiplication, and we would flip our 1/4 to get 4/1. 38 times 4 is 152, so we have 152/8. Now, I'm not 100% sure what 152 divided by 8 is, but based on what Pedro did, we can be pretty sure it's 19. Well, Cecilia, I hope that this helped you out quite a bit. I know that if you and Pedro keep working together, you're going to get it. In order to help out, I've provided this nice website, superkids.com. Now, if you want more math problems to work on with Pedro, you can go to the math worksheet section, which is on the left-hand side. Click on fractions. After you click on fractions, you can click on Basic Fraction Worksheet. This website will provide you an opportunity to come up with as many division problems as you'd like. Thank you for sending a letter in, and I hope you have a great day.